Okay, so we're going to have different types of word problems in this unit. I'm going to give you strategies for each. Okay, so this is called what I would say a chemical question. Okay, so here is the method that we're going to use to solve this. Okay, so we're going to start with chemical in a jug. So when you start with something, it's usually got, you don't just usually use just chemical, you usually combine it with water. So sometimes we're going to start with chemical and add more. Sometimes we're going to start with 0 and add chemical. And then start total fluid versus add fluid. So the fluid that I talk about is any fluid. So it could be chemical or water or both. Okay? Equals, and we're going to write percents as something over 100. So if I say 60%, it's the same as writing a 60 over 100, right? As a percent. So this is the strategy. Okay, and again, like I said, sometimes the starting chemical might actually just be a 0 because I might not have any at the start. Sometimes I might start with some, sometimes I might start with no chemical. Okay, so we're ready to see how this setup works. Okay, you have a solution. So I'm going to start with a container, and there's 20 liters in this jar. Okay, right now in this jar is a mix of water and chemical already. Before I do anything, there's already water in it and chemical in it. 40% of this jar is full of chemical. So what is 40% as a decimal? 40% of something means, to do this kind of math, times 40% of something equals 8. Okay, so that's what's happening. Okay, I'm just going to erase chemical because I'd actually rather just call it antifreeze. But you can call it that too, whatever. Okay, so right now, inside my jug, I have 8 liters of antifreeze inside the whole total, which is 20. So technically, I would have 12 liters of water in there mixing, right? Okay, ready? I'm about to add more antifreeze. I don't know how much more I want to add. So that's what's happening. I'm going to put more antifreeze in there. Okay, you ready? How much chemical did I start with? 8. Plus, how much did I add? Don't know. So a letter. How much fluid did I start with in my jug? 20. Did that level go up? Would 20 go up? Yes. If I put in more fluid, doesn't matter what kind of fluid, if it's water or the chemical, it would go up. And what is the goal to reach at the end after the added? 60% is the final that I want to get to. Okay, so there's the only part we've added. You guys know what to do now. Did you know that? Solving equations. You have two choices. What do you want to do? Should we cross multiply or common denominator drop? Cross multiply. This times should equal this times.
It was on accident.
Okay, algebra. So my algebra would start with a minus 60a. And I'm isolating, right? It's all isolating algebra, so get stuff alone, move it to the other side. So my final answer is I'm going to have to add 10 liters of antifreeze to the jug. Okay, so do you see what your total jug would look like? If you added 10, you would technically have 18 chemical liters. And if you added 10, you would have 30. So 18 divided by 30 equals 0.6, which was our goal. Okay, number 2. So these questions, T equals time worked. R equals rate. What is rate? The rate is the time for one person to complete a job. A rate is the time to complete a job for one person. That's their rate. Okay, so here's an example. It takes me, let's say, 15 hours to write report cards. Okay, 2 hours of the day has gone by. What portion of the job have I finished? Would it make sense that I'm 2/15 of the way done my job? Does that make sense to you? Okay. So a time over a rate is the portion that you've completed. So again, if it takes me 15 hours to do report cards, that's my rate. If 2 hours has gone by, that's a time, I have done 2/15 of the job. I still have a long way to go, right? Okay. So here's what we're going to do. We're going to build a little T-chart. Okay, so time, rate, we have a Jeremy and we have a Carl. Okay, I'm going to read and then we say stop, fill in. It takes Jeremy 20 minutes to push mow the yard. So is that Jeremy's time of working or is that the rate to do the whole thing? That's a rate. Jeremy's rate. If Carl is going to jump in and help, and now they're doing it together, it would take them 12 minutes. Is that a time that we've worked or a time alone? A time for a whole job alone or a time of working? Just a time of working. And it's on both of them because it was when they were working together, that was the time that went by of working. If Carl were alone, how long would it take him? So that is the unknown. We're trying to figure out Carl's rate. Okay, so now, how much of the job did Jeremy do? Jeremy did 12/20ths of the job. That's the portion that he did. Plus, what's the portion of Carl? 12/8ths of the job. And if I add together this person's portion plus this person's portion, it would total the entire job got done. The whole job. This person's, think about pie pieces. This person did so much of the pie, this person did this other part of the pie, but together they ate the whole pie. Okay, that's it for me. You know what to do. Cross multiply or common denominator drop. Common denominator, so give me fractions on both sides. What would be the common denominator so it would work for all of the items? Would you pick a 20K on the bottom? Would that make sense? Okay, now we go through each fraction. Fraction 1, there was a 20, now there's a 20K. What happened? Times by K, so the top would become 12K. Okay, I'm on the second fraction. Look at the bottom, which was K. Now there's a 20K. So what happened to the bottom of the second? Times by 20. So that would be 240. Okay, I'm moving across. Technically, what's on the bottom? A 1. So what happened? 20K over 20K is 1, right? So what do we do with the common denominator strategy? It's called common denominator drop. So really, we're done with that. You don't need to write this. I will, but you don't need to. So I'm only dealing with this top. So now, can you isolate stuff? What do you want to move around? Algebra stuff. Move, divide. So this one came out to Carl. If Carl was working alone, Jeremy wasn't helping him, it would take him 30 minutes to do the job alone. Okay, so number 3 is the same kind of example. You're going to put, you have a pool, you're trying to fill it up with water, and we have 3 different hoses going into our pool. This is what's happening. Okay, so I need a time and a rate chart with hose number 1, number 2, and number 3. And we're going to assume things about this, that your water pressure is the same. Okay, so I'm going to read and then we're going to fill in the chart. If you just used hose 1, it would take 10 hours to fill up your pool. So is that a time that it went or a rate of it doing a job? Rate. If you just used hose number 2, it would take 12 hours. Is that a time of working or a rate to do a job? Rate. If you were to just use the 3rd hose, it would take that hose 18 hours. How long does it take when you use all 3? So how long does the time take? We're trying to figure that out. And they're all going to be on the same time because it's them working together. We're trying to figure that time, and then it would all stop at the same time, right? Okay, so here we go. Number 1 does X tenths of the job. That's the portion it does. Number 2 does X twelfths of the job. And the portion of the 3rd hose does X 18ths of the job. When they all work together, they do the whole job. So now, what do you want to do? Cross multiply or common denominator? Common denominator. Okay, I need you to get me a number that is divisible by all of them. And on this one, normally I say you have to pick the lowest. On this one, it won't matter. You don't need to pick the lowest. Just pick anything that works for all 3 of them. Nope, I have to go bigger. That's a common factor. That's a common factor. I want a common multiple. You know what I mean? You're going lower. I want to go something higher. Hundreds, something. 180. 180 is a common multiple. You know what I mean? If I said you gave me a common factor, I want a common multiple. Okay, ready? What would I have to do to change a 10 into a 180? Times it by 18. Who knows this one? What do you do to a 12 to turn it into a 180? What would you have to multiply by? 15. Okay, 3rd fraction, what do you have to do to an 18 to turn it into 180? And then, well, how do you write 1? A same over a same, right? Okay, common denominator drop. So I'm done with the bottom. So I'm only going to look at the tops. So this, all this I added. How many x's? You can put them all together. Divide. So now the pool will get filled in 4.19 hours. Okay, this one is a physics-y question. Who knows the formula for speed or velocity? What would it be? Distance over time. What is the formula for time? How do you change that? If I tried to switch this formula to be a time, distance divided by speed. Okay. And I don't care about the distance ones. You won't run into that because obviously these are the ones that deal with fractions. FYI, if you wanted distance, it would be those times, right? Okay. A boat travels 9 miles upstream in the same time it does that downstream. So I want you to write time up equals time down. The time to go upstream is the same as the time going downstream. Okay, so I'm going to use this. So I'm going to put a fraction and a fraction. Okay, so you guys know what I'm doing here. I'm trying to fill in distance and speed. Okay, let's talk about upstream. Upstream. So a boat would travel 9 miles upstream. So that's going to be a distance upstream. In the same time, it would go 11 distance downstream. The current of the river is 3 miles per hour. Find the speed of what the boat can go. Okay, so no matter where you're traveling, the boat, when you max it out, it's going at the same speed. Okay? When you travel with a wind or a water current, what happens to you when it is going upstream versus downstream? Think about life. What happens when you're on a bike, the wind is at your back versus the wind's on your face? What's happening? Okay, so what happens when we're going upstream? It's going to be the boat speed. What would the water do? Would it speed you up or slow you down when you're going upstream? Slow me down. So it's coming at my face, right? That's like on a bike. It would be coming at my face. What's happening to me down speed? It's my boat speed. What would the water do? The water would make me go faster down. Okay. Also, this question, be ready for it the other way. I might give you boat speed and you got to figure out the water speed. Okay? It always has to go boat plus or minus the water speed. Do not do it the water plus or minus the boat because you're going to get either a negative answer or something crazy. So on a test, I got people that were giving me negative boat speed because they did it wrong. Does that make sense? Or would there be a red flag in your brain saying, whoa? Also, people who did it wrong on a test told me the water was going 300 miles per hour. Is that another red flag that something went wrong? Okay, what do you want to do? Cross multiply or common denominator drop? I'm picking cross multiply, right? We're looking for a boat speed. So we're looking, does our answer seem reasonable for a boat? Okay, collect variables. So which variable are you going to move? Keep going on your own. Algebra, isolate, collect, divide. And this is what we're finding is a speed of a boat. So give me some units and ask yourself, does your answer seem reasonable? Does it seem reasonable? 30 miles an hour? I'm not a boat person. Anybody a boat person? You have a boat? You ski on it? What? Oh, a fishing boat. Probably not that fast then, or maybe. Okay, we have Janelle and Tanya. Okay, time rates question. Time and rates. Janella and Tanya and time rate. Okay, I'm going to read this sentence to you first. Working together, they can do this flooring job. They're trying to put flooring down. They can do it together in 12 hours. Where would you put 12 in the mix of all of this? When they work together, they can do the job in 12 hours. That is the time that they're working. Okay, now, here's the next part. Tanya takes 18 hours longer. So, you know what I don't even know? I don't know Janelle's and I don't know Tanya's. I don't know anybody, but I know that she takes 18 hours longer. So what can I do with that? I can do Tanya, and I can write what do you want to write? J plus 18. Does that make sense? Because I don't know how long it takes Janelle, but I know that Tanya is 18 more than that. Okay, ready? Janelle does 12/8 of the job, plus the portion that Tanya does is 12J plus 18ths of the job. The portion plus that portion completes a whole job. Okay, cross multiply or common denominator? Common denominator. Okay, what do I all need in my denominator? I need a J and I need a J plus 18. I need both multipliers in there. Okay? Please don't treat J plus 18 to include a J because then it's an adder. Adders are different than multipliers, right? Okay, now we go through the process. Look at the bottom, look at the new bottom. What happened? A J plus 18 happened. So 12J plus 216. Okay, I'm moving to fraction 2. The bottom, the new bottom, what happened? A J happened. So 12J. And how do I ever write 1? Same top bottom, right? Whatever the bottom is, same top bottom. Okay, so all that's new is this equation right here. You guys know the steps for this. Okay, I'm going to put these together. So 12J, 12J, 24J plus 216. My J's are looking like 5s for some reason. Okay, on this side, what are you going to do with this top? I'm going to do stuff to it. What am I going to do? I should distribute Okay, are you ready for grade 12? What do? You see J squareds, you see J's, you see numbers. What are you going to do? Just like that. 0. Yep, you need a 0. Who's the boss here? Who's our boss? J squared is the boss, so it's going to stay. So you need to do a minus 24J and a minus 216. Then it gives me a 0. Okay, so what do you do now? You made it 0. It looks really nice and pretty now. What do you want to try? Simple trinomial stuff? Okay, so what multiplies to 216? My hint is up here. Look at what you did. 12 times 18 was 216. Do 12 times 18. Can you get a 6 out of 12 and 18? Yeah. What if you just really couldn't find those two factors? What else could you just do? There's always a what? Formula. There's always that quadratic formula too. So I need to get a minus 6 and a negative 216. So that's working, right? So Janelle takes 18 hours or Janelle takes negative 12 hours. What do you know about this answer? She takes negative 12 hours to do the job? Question mark? Doesn't make sense, right? So Janelle takes 18 hours. How long does Tanya take to do the job if she's working alone? What's 18 longer than that? 36 hours. Okay, I'm going to save the number 6